Hello and welcome to this video. In this video, we're going to be analyzing PIAAC data. And the first part of this video, we're going to predict adult literacy uh, with plausible values as a dependent variable. And after that, we're going to be predicting reading behavior at home. And in this case, plausible values for reading literacy will be an independent variable. So you should have our script handy, and this script is made by myself and also primarily my colleague Kaidir Nurumov. So let's get started. So in order to understand the data that you're working with, you need to download the codebook, and you also need to download your data for your country. For this example, we're going to use Austrian data. I would put the Austrian data or your data set in .sav form alongside the codebook into your working directory, which is just a folder on your desktop, perhaps. If you'd also like an overall rationale for this script, you can obtain that from me or my colleague. Okay, so let's get started by making a link to the working directory. You can do this by script, or you can do it manually as well. Good practice is to clear the working directory in the right-hand quadrant. Make sure that you have the latest version of R in RStudio. That's always good practice. I use the Pacman package to load and manage packages. So if I need to install or load any packages, I can use this function here on line 44. Now we're going to read in the data. Our data should be somewhere in our working directory. So we read in the data with the foreign package, and we're reading in the SPSS.sav data. Shouldn't take too long. You can see the data up here. So let's start with defining the dependent variables. Remember, we have 10 plausible values for PIAAC, but we can start by just looking into the first one. We can see the summary. We can see the minimum and maximum for Austria. We can have a look at the total number of missing values. There are none. We can look at the structure of that variable. We can see that it's a number. And we can also use the describe function to get general descriptive of that single plausible value. Okay, but we need to manage all 10 plausible values to do our analysis. Now, let's move on to the independent variables in the regression model. We want to code female as 2 and male as 1. We can check these data. We can see it's a factor. Let's define it as a numeric in this case. See, there are more females than males. Let's also look at age as another independent variable. In this case, we're going to just check the variable, and it's categorical. There are no NAs. We can see that it's a factor. But let's also code this as a numeric, and this will be our quasi-continuous variable. Here, we're just coding it as 1, 2, 3, 4, 5, but you could code it as the midpoint for the age. It's up to you. Native language is our other independent variable for our model. We can check these data, and we're just going to code it as numeric. We can see that we have most of the time test language is same as native language, but sometimes the test language is not the same as the native language inside Austria for these adults. So we can just code, and we can see that most of the time we're coding it as 0 or 1, and most of the time it's 1, as in no, it's a native language. The test is set in a native language. Let's check our weighting variables. We have our final sample weight and replicate weights. We also have sequence variables. You can check those out. Let's focus on data manipulation. Let's just select the variables that we need from the data frame using this select function. So now we have a 95 column data frame, 4,565 variables. We can standardize the focal variable for the study and just add that as well. We can say that the focal variable for this study or this model is age. And we're just standardizing that. You don't have to, you can model it however you like. Let's focus on using complete cases only. So now our data set drops a little bit. Check our predictive variables. Check out dependent variable. Which column is our dependent variable? It is columns 5 all the way to 13, and we demonstrate that here. Okay, final check, and let's focus on which variables in the data frame are the plausible values. They run from the 5th to the 14th. So the names of those variables are here. But this might change to numeracy for you if numeracy is your focal variable, focal dependent variable. For here, we're going to switch back to as factor. Just to replicate the IDP analyzer. But it's up to you how you want to model these data. Let's focus on running the model 10 times for the average overall regression coefficient. We run the L-apply model. Manipulate the results and get our overall intercept for the model and our coefficients here as well. So we have our overall intercept and our coefficients, but we don't have our levels of statistical significance. So we need to move on and continue with the modeling. Let's focus again on the sample replicate weights, 16th to 95th. Now we need to find the position of those replicate weights in that data frame for these functions. We can see that those are the positions there for those 80 replicate weights. We can just run this as -1 for the rep n. That tells us how many total sample replicate weights there are. And we use this in our functions. Let's now run the functions. for imputation variance, our next function for sample variance, and we can now move on to running the models 10 times to generate variance due to imputations. Here's a full annotated model for just plausible value 1. You can see that here. If you're interested in the math, you need to read our paper on that with all the formulas. Plausible value 1, plausible value 2, plausible value 3, 4, 5, 6, 7, 8, 9, and 10. So we run the model 10 times with each plausible value. Make sure that you do everything correctly. So let's work out the variance due to imputation or plausible values. We establish that with our function. Next, it is variance due to sampling. This is established. Now we combine the variance due to sampling and imputation or plausible values. There we have it. Next, we move on to calculating the t-values. Okay, so this is the overall coefficients divided by the total standard errors will give us our t's. Now that we have our t-values, we can now move on to finding the mean for the degrees of freedom for all PVs. Let's move on to that. Now we are moving on to the corrections, which are given in the Word document. Finally, we move on to the adjusted p-values for the coefficients, and we can dress up the data frame and report the final results. So these don't change, the coefficients don't change, but remember we have standard errors that account for imputation and basic standard errors or sampling. We have our associated t-values, which is just the coefficient provided by the standard error. We also have our adjusted degrees of freedom. All of these together give us our p-values. I hope this is clear. Notice that I adjusted the scientific pen so we get our full results here, so it's easy to read to whatever decimal points they are. But these are all our results, and this is what we can report in our table in whatever format we might be using. Okay, so this is our calculation of multiple regression using plausible values as dependent variables. Let's now move on to plausible values as independent variables. So in this case, our variable of interest is going to be a variable that reflects the type of the level of reading that an adult partakes in at home. So let's have a look at the structure of that variable. Okay, it's a factor with many levels. We can see multiple estimates. It looks here to like it's a type of maybe a rash estimate for the level of reading at home, which is, it has a similar range. Often it has a similar range to a z-score, but it generally ranges between -4 and 4, depending on how it's centered. We can have a quick look at the summary. Okay. Let's shift it to a numeric so it's easier to deal with. Remember, as we're shifting from factor to numeric, we go through the character coercion as well. Let's move to the data manipulation step. Let's just select the variables from the model that we need. And again, we're going to switch them back to being factors. My colleague did this to align the results with the IDP analyzer. I did it a little differently, but my colleague switched it back, which is fine. Let's standardize the age variable for the study again. Okay, that's done. And we want to use complete cases only. So we use this complete cases function. I think it's base function, is it? You can check. Yeah. Oh, it's a stats function. Anyway, it's a useful function. Whenever I use it, I like to put a dimension before and after. Check. So we've dropped a little bit, not too much. Okay. Let's move on to just a final variable check. Okay, looking good. Check for our independent variables. We can check the plausible values because they are the independent variables now. Gender. Let's check gender. Okay, it's coded 1 and 2. 2 for females. Native language. This is an independent variable again in the model. Okay, we can see the results there, pretty similar. And we have our age result, which is standardized, which is fine. Okay, so let's establish a series of plausible values. Again, we can select which columns they are, 6 to 15. Those are our names, PV names. This will change for your focal area. It could be numeracy or whatever. Okay, so here's our function to run for the overall regression coefficients, right? And we're using, I should have explained it before, but we're using the final sample weight here, not the replicate weight, just a final sample weight for the overall coefficients. And here they are, intercept, coefficient 1 for the plausible values, in fact, for all of them. And then the effective gender, the coefficient for gender, the coefficient for age, and the coefficient for native language. So remember, we're predicting the reading at home variable. Okay, create functions for sampling due to sampling. Create functions for variance due to sampling and plausible values. So we can do that now. Again, we need these replicate weights here. What are their positions? 17 to 96. Let's double check. Correct. Those are the row names, column names, replicate weight names. I mean, RW means replicate weight names. So let's create the function for variance due to imputation. Next, function variable variance due to sampling variance. And we run it 10 times for each plausible value. Okay, notice all the changes here, here, here. See here, plausible value 1 is used in this first model. This has changed. The weights change. Okay, let's run it. That's for plausible value 1. Next is plausible value 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice the differences, everyone. Notice how it's coded. Here's our dependent variable. These are now independent. Let's move to the calculation of variance due to imputations. Next, variance due to sampling, combined for these standard errors, t-values. Next, we calculate the overall degrees of freedom, implement the adjustment, and calculate our adjusted coefficients and dress them up in table form, and here we have it. So the outcome is the focus on reading patterns at home, and you can see that this is our intercept here, and we have the predictors. It seems like we have two predictors are statistically significant over the 0.05 or under the 0.05 threshold. We can see that gender is not important, and even native language is not important. Age seems like the older you get, the more likely you are to partake in reading at home as an adult. And of course, we see the effect of literacy as well is an important predictor of reading patterns at home, or the focus of those focal variable, which is index of use of reading skills at home, prose and documents. Okay, so I hope this is helpful. Thank you very much for your attention. If you have any questions, please put a note in the video and my colleague and I will surely respond. Thank you so much. Bye-bye.